Properties of the mid-segment. What did you figure out there, Jack?
About the first one?
Yeah, the first one. What did you figure out?
Figured out the mid-segment of the trapezoid is always parallel to the two bases.
Okay, that's one thing, right? You figured out that this slope is always going to be the same, right? And so it looks like 0, but that's because I have my rounding set. If I drag it, right, all the slopes change to 1, right? Right? And if I drag it more, oh look, now all the slopes are 5. Wait, all the slopes are 3 or 3 here, right? 3 over 1, and so on. So the slope does change as you drag it. Who else can tell me something? What if I squish it? How do I squish it? There, I could squish it. Can I squish it? There, I could squish it. Who can tell me what's true about the relationship between the lengths of the bases? Go ahead, Ben.
So if you take the average of the bases,
Very good.
you get the mid-segment.
Very good. So, did you guys all discover that? If you add up the top piece and the bottom piece, you get the and divide by 2, you get the mid-segment. Okay. So I have a couple just examples that I want to. Well, first let's just go through these conjectures, which I have. I want to grant the 3 mid segments. Oh, we're not done yet. We didn't talk about the triangles, right? So then if we take that, where did it go? If we take it and we make it into a triangle by dragging this to there, like that, who can tell me now what the relationship is between the base and the mid-segment? Go ahead, Drake.
The mid-segment is half.
Very good. Mid-segment is going to be half of the base, right? So notice that if I drag this, that mid-segment is always, whoops, that's because it's rounding up, okay? But because it's rounding, that's why. But this is 8, that's 4. When this is 12, that's 6. The reason it wasn't, it's rounding up to the nearest tenth. But so in that case, and is it still parallel? Are those two things still parallel? Yes, they are. Okay. So let's go through and fill in these conjectures. The other thing. Hey, turn around. The other thing that is true that I didn't totally show you is that if I were to connect all 3 midpoints in a triangle, let's see, I can do that on here. They didn't talk about that on the, but if I put go here, midpoint at center, and I go here, no, that didn't work. Edit, undo, I want to put a midpoint at center, and I click on this. Where's my midpoint? That is a midpoint?
Oh, it's hidden under the AD.
Where is it?
It's hidden under this thing.
Oh, it's hidden under there?
You can see the little dot.
Oh, let me move that. Oh, there it is. Okay. If I connect all of these, so I'm going to take a segment, I'm going to connect it from here to here, and then from here to here, and I drag this thing around. Okay. Watch. What appears to be true about all 4 of those triangles? They're congruent. Okay. That is true because watch. If this is a mid-segment, this has to be congruent to this. Yes? And this has to be congruent to this. Right? And this has to be congruent to this. And since this we discovered is half of this, how many marks should this piece have on it? This should have 2. Do you get that? Right? Because if this is the whole base, then this is half of that, so that would be one of those. How many marks should this have on it? 1, right? And how many marks should this have? 3. So what's true about all 4 of those triangles? Why? Side, 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 right? They're all congruent by side, 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 orienting them in the correct. Well, these are all oriented the same way, but this one is upside down, right? See that? Isn't that kind of cool? All right. So let's go through and fill in those conjectures on your conjecture sheet. The 3 the three, and then I do a couple example problems, and then I want to grab that picture to put it on my notes. Where did I go? Where's that? Grab that picture. There it is. Grab that picture. Grab it. Is that my picture? That's my camera. Partial place capture. Partial. There we go. Oh, I wanted the last. Anyway, going back to the three mid segments of a triangle divided into four congruent triangles. Okay. And then on this conjecture, C42, a mid-segment of a triangle is blank to the third side. What goes there? You guys just discovered that. Not congruent to the third side.
Third side of the base.
Hello? No one? What about the slopes? What do the slopes tell you? If the slopes are the same, then the lines are parallel. That's what goes on. Okay? Well, did I spell that right? I think so. To third side and blank the length. Half. Okay? Half the length of the third of the base. Okay? Or the third to the third side and half the length. The mid-segment, half the length of the third side or the base, third side. Well, there's three different bases depending on which way you're looking at. Trapezoid, the mid-segment of a triangle is, what goes in here? Length to the bases, same thing as up here. What goes there? Parallel, okay? And we figured out that it is equal to in length to the average, which you guys figured out, okay? Average of the two bases, okay? So I'm going to give you just a couple quick examples, and then I'll let you work on your homework, which I think you'll find pretty easy, okay? So, so say, for instance, they give you a picture that looks like, let's get a picture. Well, there's a trapezoid. Make a trapezoid. And I pretend that this is a midpoint, this is a midpoint. Where's that tool again? I'm going to connect this to here. Okay, perfect. Straight, get straight. Okay. And if I say this, I tell you that it's a trapezoid by indicating that these two sides are parallel. If I tell you that this is 20 and this is 8, what is this piece right here? What's that piece? 14, right? 28, so this is 28 divided by 2, which is 14. That's easy enough? Okay. What if I were to tell you that, to tell you that this side here, what if I were to tell you that, let's make another trapezoid. Trapezoid, make a trapezoid, mid-segment, perfect, okay? What if I were to tell you that this side is 6 and this side is 3? How do I find this over here if it's a trapezoid? And that's a mid-segment. How do I find x? How do I find x? What is x? What's x? 9. How do you get that? 3 plus 9. So you kind of did that, and you can make a little equation. if 6 is the average of the two bases, you can say that 3 plus x divided by 2 equals 6, right? How do I solve that? Algebraically, how do I solve that? Multiply both sides by 2, right? That goes away. I get 3 plus x equals 12, x equals 9. Easy enough? Okay? Let's do one more example with some algebra stuff in here. Okay, so say I were to give you a triangle, okay? And try to give you a triangle, new piece of paper. Triangle, let's make a triangle. Make a triangle, there we go. Make a mid-segment. There we go. Mark this, mark this, mark this, mark this. Couple things. Say I told you that this angle was 40 degrees. What would this angle up here be? What would A be? What would A be? 40. Because it's a mid-segment, we know these are parallel, so those corresponding angles have to be equal. What if I told you that this side was, what if I told you that this was 20 over here, and this is 5x plus 10, okay? And I say find x. Could you do that?
Yeah.
How? Who can tell me how to find x? What's true about the relationship between this and this? This is half, right? So if I do what to this, I get this. Multiply by 2. So I know that 2 times 20, right? Since this is half of this, double this would have to be equal that, right? Equals 5x plus 10. Got it? Okay, so 40 equals 5x plus 10. So 5x equals 30. X equals 6. Right? Okay? So, you can start on this first set of homework, and then we'll talk about properties of parallelograms in a little bit. Okay? So the first set of homework is page 277. Page 277, 1 through 8. And then 11, 12, 14, and 15. Yes, sir.